Okay, so friends, we are going to do some stop starts of today. Meaning, so page 149 we did yesterday, like that should be done. Agree? Yeah. That's part of the review. Will you please work on page 150 and page 151? And what do we say? We'll do about 15 minutes, and then we'll go over them. Sound like a plan? Cool. Thank you. All right. Here we go. So I'm on the second page, the 150, I guess it is. It says a study of the Intermap research group collected data and looked for a relationship between cholesterol level and systolic blood pressure. The resulting finding was a low order positive relationship existed. Okay, so they're using a term called low order, which basically means that your data would probably like be kind of it doesn't look like the best R value you'd get. I'd say that's what they're trying to refer to. So in this case, the phrase low order means weak relationship. Explain what this means in the context of our problem. We probably just can't predict blood pressure from cholesterol in a really good way. I mean, other ways that we could do it is maybe collect more data to get a better line of best fit. But low order probably would mean that you have an R value that is positive, and it's probably like 0.3, 30%. Okay, so you just know with that it's not going to probably be good. Oh, it looks like they actually gave us 0.186. So that's an 18.6% on the test. Good or bad? If you're in CP Algebra 1, you'd probably say, dude, that's awesome. Saying I got a chance. Huh? That's true. 18.6 though. Percent. That'd be good then. All right. So they give us this equation. Hey, friends, when you have the hat on top, what did I say that basically meant yesterday? Anyone recall? What did the little hat mean? The hat means I would have gotten my equation by data. That's all it means. So if you start seeing hats on stuff, that just means that they got a line of best fit. They didn't just arbitrarily make it up. It's like they had gotten data, the line of best fit, that's what it would have taken place. All right, so number 9 says, number 9, there's actually an error because it says predict the cholesterol level if the person has a cholesterol level. Number 9 is you're supposed to predict the blood pressure. That was an error on our part. Blood pressure of Mr. Robertson, who had a cholesterol level. So the cholesterol level was 206. Okay, so if you look at the information, the Y hat value is the predicted systolic blood pressure, X is the cholesterol. So if this guy had a cholesterol of 206, I'm going to go plug in to our equation, 486, and I'm going to replace X with the 206. And realize they have this linear equation where you have the y-intercept first and then the slope second. If you wrote it the other way, you're fine. Okay, so if this person had a 206, then if you did this math right here, just by using a calculator, come up roughly with 84.7. Okay, interpret the slope. So the slope of this regression model, first off, my slope is this, 0.06486. And you have to remember, slope is the change in the y direction over the change in the x. So you talk about what's going on in the y direction. The y direction is systolic over cholesterol. Okay, so this means that if I have a slope of 0.06486, if we put it over 1, our systolic rate will go up 0.06486 for every increase of 1 cholesterol. That makes sense? Well, hi. Then number 11 says, talk about what the y-intercept means in this problem. So our y-intercept is this. So this basically means is if your blood pressure is equal to 0, then you're dead, but your cholesterol's low. So that's kind of a, that would be an extrapolation. That's outside of our data because obviously your blood pressure shouldn't be 0. If it is and you're still alive, you better go see a doctor. Then number 12 says, interpret the x-intercept. So if I want to do the x-intercept, we have to remember this. I'm plugging in 0 for our y value. So I'm going to take my equation and go 0 equals 71.3333 plus 0.0648 x. And you're going to use algebra 1. You're going to solve for x. If you solve for x, this is going to tell you that if your cholesterol level is equal to 0, then your blood pressure is negative 1099.8. I don't know a lot of things, but I know just enough to make me dangerous. I don't think you're going to have a blood pressure that's a negative number, first of all. So, but that's just kind of what the data is showing. And then number 13, if your cholesterol level goes down by 20, so I'm reducing 20. So going down 20 means what? If I go down 20, add or subtract, or positive or negative? If I go down, positive or negative? Negative. Okay. So I'm going to take that negative 20, and I'm going to replace that for x on my equation. So I get y hat equals 71.3333 plus 0.06486 times negative 20. Did you do it? Yeah. What'd you get? I got 70.0361. 70 what? 70.0361. 70 point. Okay, so about this. Cool. All right. So, you know what the question asked? If we're going to go down by 20, this is all the math that I'm going to do right here. Will someone do that for me? 0.06486 times negative 20. Anybody? 1.29? Yeah. So we would go down 1.29. We gone. We go down. Okay, so I guess in the context of the problem, we lower down 1.29 if we decrease by 20. And then your overall would be 70.3. So I think this would be the answer they're looking for. That's kind of a tricky one. That'd be one probably in an AP test they would nail you on. If you did it in here, if you gave me the answer of 70.3 versus 1.29, I'd probably give you credit either way. Okay? All right, number 14. Says, do you feel that changing your cholesterol level will directly result in a change to your blood pressure? We're going to say no. And then this is one of the most important things that we talked about a while ago. Correlation does not imply what? Causation. Okay? So that's one of the things that we have to be careful with. Correlation does not imply causation. Unfortunately, society says, oh, there's a correlation, therefore this must be. And you're like, you're wrong. All right, number 15. Looking over this information, what do you take away from the research? You could say anything. I mean, there's things that we have to know. We had an R value of 0.186. That's horrible. Okay, that's much closer to 0 than it is to 1, so it's horrible. So you can't really make a prediction that this works. You can't say controlling your cholesterol probably has very little impact on blood pressure. That's what you could take away from it, but you can't really guarantee it. Okay, because that R value is so cruddy. So because R is bad, and we know that correlation does not cause causation, that controlling your cholesterol probably has little impact on your blood pressure. Does it? I'm just basing off of what they're saying. And then I'm on page 151. Are there any questions for me so far? Doing okay on time. All right, look at the following scatter plot. Okay, so you have a scatter plot that kind of does this. And you have data points all around it. Then you got one that's up here. All right, what is the response variable? So you have weight over here, and you have height. So number 16, the response is the Y. It's our Y value, and so in our case, the Y value is weight. Okay. How many data points produce response variable observations that are higher than the regression equation would predict? So what you're going to do is you're going to count There's 3 teachers out there. We should be safe. I ignore it. Everyone else comes out. What's going on? People come from the main office. What's going on? All right. So if you count all the data points on the graph, it looks like there should be 9 data points above. All right. And then number 18 says, look at the data point with the highest value for the response variable. Draw the segment that represents the residual for this point. So you're looking for your highest point. If you look for your highest point, you basically just draw a straight line down. That would be your residual. That, in this case, it would be positive because it's above. If it was below, it would be negative. That actually comes in the next section a little bit. And so estimate the residual for this data point. So I think if you look at this data point and you came this way, it would be at about 150-ish. And if you came down to the line of best fit to like right here, I think it's about 120-ish. So if you just subtract the two, so about 30-ish. So again, you're looking at a graph that's not exact. So, I mean, there's multiple answers. If you wanted to estimate the correlation between this, if you were to look at our correlation, what do you guys think? What do you guarantee it is? What do you guarantee the correlation of that graph would be? Without knowing a number, what do you guarantee what it should be? Positive or negative? Positive. Why? Yeah, so I guarantee I have a positive. Now, there's a lot of wiggle room here. I mean, we could get probably answers between 30 and 80, and I think you're appropriate on that. Okay? If you want to put 82, am I going to dock you? No. Okay? So there's moderate, positive. So I'd say it's moderate, positive. Okay? Moderate doesn't have to be the word you use. You could say slight positive, kind of positive, okay positive, somewhat positive. Your verbiage is going to be correct. And then number 20, is it possible for the scatter plot to exist in which every residual value is 0? What do you think? The residual, remember, is this. It's the distance above and below the line that we are. So do you think I could get the residual value, the residual, to be equal to 0? Which means this. Could I ever have a distance that is 0? Distance of 0 is right there, and 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 right there. So in order to have a residual of 0, means all of your points fall right on the line. Okay? What might the scatter plot look like? Well, we have it right there. And then is it possible to have every residual being positive? So if I have a line of best fit, is it possible that I have only data points sitting above my line? No. Okay? So your line of best fit, unless you did really bad in science, which I might have, I don't know, could have fallen in there. So, my friends, we do have a quiz tomorrow. Will you have your half sheet? I'd say make sure you go over these pages. Make sure you go back and see any definitions prior to the chapter. It's a 19-point quiz. Have a great day, friends. Take care. If you need to come see me at homeroom, please do.